I am going to be on page 50 of the textbook, but I want to illustrate something for you first. I want you to study this picture. I just went to the internet and found a random picture. And I want you to think about all the ways we could compare these children. Okay? What are the attributes of these children that we could use to compare? And you can pause the video if you want to and think about that. Just list as many ways as you can think of to compare these children. Well, clearly I could compare them by gender. I can compare boys to girls. I could compare them by the colors of their clothes. Red shirts to blue shirts, green shirts, purple shirts. I could compare them by hair color, blondes to brunettes. So blonde girls to brunette boys, or blonde boys to blonde girls. You could really get into a lot of different comparisons for these. But for this example, I want you to write a ratio. Sorry. Write a ratio in all three forms of brunette girls to, there's that word to, that's so important, blonde children. In all three forms. And you can pause the video if you want to. So the first thing you want to do is establish the comparison. And when I taught in a classroom, I did not accept these assignments in the beginning if the words were not there. And I know that sounds heartless, but I wanted my students to learn to write the words first. As we got better at them, that changed, but because the habit was there, they didn't need to be reminded. But you always want to start with the comparison that you're making. So brunette, that means dark-haired, girls to blonde children. So let's count the brunette girls. Those are the ones on top there in purple, and it looks like there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 of those brunette girls. So let's put that up here for this value. And then blonde children, there are 10 of them because that includes boys and girls. It's going to include any child with blonde hair. So the ratio of brunette girls to blonde children is 10 to 10. And this can be simplified because if I divide the top and the bottom by 10, I will get a simplified ratio of 1 to 1. Now, can I just go ahead and simplify that on down and say 1? No, because if I do that, I'm eliminating either the brunette girls or the blonde children, and I don't want to do that. I want to keep the comparison clear. So for every brunette girl, there is one blonde child. Okay, let's try a couple more. Let's write a ratio of blonde girls to brunette girls. Okay, so then I'm going to set up this same type of frame. You want to have the words and your ratio. So we have blonde girls to brunette girls. And this is just the symbol for female. So blonde to brunette. So you have 6 blonde girls to 10 brunette girls. That's the ratio. And this one is going to simplify by 2. So 2 into 6 is 3, and 2 into 10 is 5. So let's see if that indeed turns out to be true. So for every 3 blonde girls, there are 5 brunette girls. And that's true. We end up with 2 sets of them. And that's why I could reduce by 2. There are 2 sets. Let me do it this way. Here's a set. And then you have another set just like that. Okay, let's do a couple more. I'm just building in some theory here without really calling it theory. Let's write a ratio of green shirts to blue shirts. Green shirts to blue shirts. So we want to set up the words first. I'm a firm believer that that's the most important part, because if you don't get that part nailed down, you're going to miss the whole problem. So green to blue. Count the green shirts. 1, 2, 3, 4, 5, 6, 7, 8. And the blue shirts are 4. So can this group be simplified? It sure can. We can simplify it down by 2. So we can say 2 into 8 is 4, and 2 into 4 is 2. So we could put 4 green for every 2 blue. So let's see if that works out. There are 4 green to 2 blue. And then we would have another group just like that. So 2 groups. But this will simplify further by 2. So 2 into 4 goes 2 times, and 2 into 2 goes 1 time. So this is saying that for every 2 of the green shirts, there's 1 of the blue shirts. So there's 2 greens and 1 blue. And sure enough, that can be duplicated again and again and again. Okay, so you can break them up that way. Could we have done this? At this 8 to 4, we could have broken this up to 2 over 1 immediately. And just remember that this is a unit rate when you have a 1 on the bottom. So you always want to take it to lowest terms if you can. Sometimes you cannot take it to lowest terms. But in this case, because each of these groups of people are divided into even numbers, this was a good example for me to reduce on. Okay, here's one more. I want a ratio of purple shirts to all students. And if you want to pause the video and see what you get for this answer, that would be a good idea. So remember to set up the words first and then the ratio. So we're going to have purple to all students. So the purple shirts are 10, and then all students. So we have 10 plus 6, that's 16, plus 4 is 20, plus 8 is 28. Now this one won't go to a unit rate, but we can definitely simplify by 2, top and bottom. We will get a 5 on the top and a 14 on the bottom. So this is called a simplified ratio, and you always want to do that if possible. Now let me show you how to do this on the Casio calculator, just in case you may not know that. I'm trying to draw a button for my squares because I want you to know that these are calculator buttons. And let me just put in some. The first button that you always want to press is all clear, because you want to clear out the calculator's memory. If another student has used the calculator before you want to be sure that that student's problem is not stored in there somehow. So let's press all clear and then type 10, the fraction key, 28 equals, so I have one too many boxes. And let me try that just to be sure I'm telling you correctly. And you will get 5 over 14. Same thing. It's just your calculator's way of showing you a fraction. Okay, I'm going to stop this video and we'll look at the definition of a proportion. This will be on page 50 of the textbook.